Imagine an alien moon where the ground is literally boiling beneath your feet. Rivers of glowing lava in neon colors, geysers of ice and fire exploding into space. Stay with me, because in this video you'll see how such a moon could actually exist. By the end, you'll know what drives volcanic activity on alien moons, how it compares to Earth's volcanoes, and why these violent worlds might secretly be the best places to search for life in our solar system and beyond. Picture this. You're standing on solid ground, then the surface trembles, and suddenly a fountain of glowing material shoots up into the sky. That fear and fascination humans feel on Earth, it could be multiplied by 10 on an alien moon. Let's start simple. What is a volcano, really? On any world, a volcano is just a place where the inside of the world escapes to the outside. On an alien moon, that inside could be molten rock, liquid water, or even slushy ice. On Earth, volcanoes are mostly powered by heat left over from formation plus radioactive decay. But on some alien moons, there's a different engine, tides. Not ocean tides like on Earth, but the rock itself flexing and heating as it orbits its planet. Think of bending a paperclip back and forth until it gets hot. Now replace the paperclip with a whole moon, and the hand with the gravity of a giant planet. That friction inside the rock can melt it and feed enormous alien volcanoes. One of the most extreme examples in our own neighborhood is a moon like Io around Jupiter. It's covered with hundreds of volcanoes, constantly reshaping its surface. Lava might burst so high it almost escapes the moon's weak gravity. On such a moon, the surface would look young and fresh because old craters get buried under new lava. Instead of a quiet, dusty world, you'd see a constantly changing map of lava lakes, glowing cracks, and expanding dark flows. But not every alien moon volcano spits fire. Some moons far from their star are so cold that lava might actually be water mixed with ammonia or methane. When it erupts, it forms icy flows instead of rock. This is called cryovolcanism. Imagine standing there. Instead of black ash, fine ice crystals slowly fall around you like glittering snow coming from an icy geyser. No flames, no smoke, just pale blue plumes quietly reshaping the frozen landscape in slow motion. So what decides whether a moon has rocky volcanoes or icy ones? Mostly temperature and composition. Closer to the star and massive planet, rock can melt. Farther out and made of ice, then ice becomes the stuff that flows and erupts. Now you might wonder, what triggers an eruption in the first place? On an alien moon, pressure can build up under a crust until it cracks. Once the crack opens, molten material or icy slush rushes upward, releasing energy in a sudden burst. These eruptions could even blast material into space, forming thin rings or clouds around the planet. From far away, you might see a faint halo made from countless tiny particles, all launched by volcanoes on a single restless moon. Here's where it gets really exciting for life. Active volcanoes mean a world that isn't dead inside. Heat, chemicals, and liquid. These are three key ingredients that many scientists think are crucial for life to appear or survive. On a rocky alien moon with constant eruptions, lava could release gases that build a thin atmosphere. Even if it's too hostile for us, such an atmosphere might protect more delicate regions underground or under surface ice from space radiation. On an icy moon with cryovolcanos, eruptions might open temporary windows into a hidden subsurface ocean. Plumes spraying into space could carry tiny particles from that ocean, giving us clues about what's happening far below the ice. If this reminds you of geysers on Earth, that's not an accident. The same physics, pressure, heat, fractures can work on worlds made of very different stuff. The big difference is the scale. An entire moon can act like one giant, unstable geyser. Now imagine an alien moon in another star system. Strong tides from its giant planet, a slightly eccentric orbit, and maybe a mix of rock and ice. The result could be a wild hybrid, fiery lava plains near the equator and icy eruptions near the poles. Could such a place host life? Maybe not on the scorching lava fields, but perhaps in protected pockets underground, or in layers where hot rock meets buried ice. There, water might stay liquid just long enough for chemistry to get interesting. And what about the skies above this alien moon? Volcanic plumes might fill them with colored hazes, reds, greens, blues, depending on the gases and particles. During each eruption, the whole horizon could shift color like a slow-motion light show. You might see distant fireworks as other volcanoes erupt along the limb of the moon, their plumes curving under low gravity. Instead of quick explosions, they'd rise gracefully, hang for a while, then softly rain material back down. Over millions of years, all this activity reshapes the whole moon. Mountains rise and then collapse, plains form from cooled flows, old features vanish under fresh deposits. The surface becomes a record of endless eruptions and quiet pauses. For future explorers, active moons might be both dangerous and valuable. Volcanic heat could power habitats, while volcanic materials could provide resources. But land in the wrong spot at the wrong time and you might be buried under ejecta. From orbit, spacecraft could watch how eruptions change over time. Measuring the brightness and composition of plumes would reveal what's happening deep inside, how much heat, what chemicals, and maybe even hints of complex organic molecules. We might even catch new volcanoes turning on and old ones fading away. Just like weather on Earth, this volcano weather would be a dynamic system, sometimes calm, sometimes stormy, always shifting over days, years, and centuries. So why does all of this matter to you, watching this video at home? Because alien moons with volcanoes are not just background dots in space. They might be the most active, dramatic, and potentially life-friendly worlds we'll ever discover. As telescopes improve, we may soon detect signs of volcanic activity on moons around distant stars. Changes in their light, strange gases in their atmospheres, or even brief glows could all be clues that something is erupting far away. Stay with me to the end, because here's the key idea. If we find a volcanically active alien moon with the right chemistry and temperature, it could be one of our best bets for finding life. Not on a planet, but on a wild, restless moon. So next time you see a picture of a distant planet with tiny specks around it, remember, one of those specks might be a violently active alien moon, with volcanoes lighting up the dark and maybe, just maybe, sheltering something alive within.